Companies today are integrating generative AI at a breakneck pace. The initial prototype works, the demo impresses the board, and everyone rushes to ship. But beneath the surface, the system is already swaying under its own weight. This instability is AI technical debt. Prioritizing immediate deployment creates a high-interest loan on your future infrastructure. Shortcuts taken during the prototype phase reappear later as maintenance costs that outpace the model's accuracy. Traditional software engineering is deterministic. Give a program a specific set of inputs, and you get the exact same outputs every single time. When engineers rush traditional code, they end up with spaghetti code, messy and difficult to read, but still predictable and testable. AI is probabilistic. Because these models rely on statistical weights and deep context, changing one single input sends ripples through the system. Even with identical inputs, the results can shift. This sensitivity makes probabilistic systems difficult to audit and control. Without a rigid architectural foundation, an AI deployment scales into an opaque liability, where you can no longer explain why the model makes a specific decision. Unchecked AI deployments create a fast track to organizational risk, bypassing genuine innovation in favor of long-term instability. To solve this, we categorize the debt into 4 pillars, starting with data debt. An AI is a reflection of its training set. Relying on unvetted sources introduces vulnerabilities, like data bias, poisoning, or the accidental exposure of personally identifiable information. Treecapital developed the Anven ecosystem to secure this foundation. It integrates conversational logic directly with your own verified corporate data. This shows how Retrieval Augmented Generation, or RAG, operates. The system intercepts a user query and forces the AI to consult a secure, real-time database of internal documents. If the answer isn't in your vault, the AI is programmed to stop rather than guess. The second pillar is model debt. Teams often deploy models based on vibe checks rather than empirical testing. Without strict versioning or performance benchmarks, you lose the ability to measure accuracy or safely roll back the system when it fails. This is Treecapital's application evaluation framework. It moves organizations from subjective impressions to deterministic unit testing. The success metrics below define operational targets. Anven 3B acts as an automated judge, verifying resolution rates above 80%, toxicity below 0.1%, and high-quality scores. Anchoring evaluated models to verified corporate data establishes a baseline of truth. This evidence-based approach is required for autonomous systems to remain reliable at scale. The third pillar involves prompt and execution debt. Undocumented system prompts and overprivileged agents create security holes. Attackers can use prompt injections to hijack the system, or an agent might call the wrong tool and trigger an integration failure. This dashboard monitors those execution risks through Anven Guard 4. This safety layer sits between the user and the model, screening for malicious intent and monitoring the integrity of every response to keep toxicity failures below the 0.1% threshold. We prevent agents from going off script by using deterministic output structuring. Instead of allowing the AI to generate conversational filler, the system forces the model to return exact data payloads, such as raw JSON. And the fourth pillar is organizational debt. Relying on public multi-tenant APIs exposes the business to unpredictable latency, runaway costs, and the exfiltration of sensitive telemetry to external vendors. This framework details the move to sovereign infrastructure. The center pillar shows deploying Anven within an air-gapped private cloud to maintain absolute data ownership. The efficiency pillar on the left shows how quantized models run locally on consumer hardware, reducing overhead. Reliable enterprise AI performance depends on complete governance across the conversational logic and the underlying hardware. AI technical debt is an exponential liability. Attempting to fix a broken probabilistic system while it is processing live enterprise traffic is a high-cost, high-risk operation. This graphic illustrates the transition from generic AI experimentation to sovereign engineering. We are moving from the blurry, opaque outputs of public models to the highly structured, deterministic grid of the Anven Enterprise Framework. This is Treecapital's migration strategy. It provides a sequential path away from legacy APIs, moving through assessment and proof of concept into incremental migration and optimization. By adopting the Anven ecosystem, technical leaders arm their organizations with an architecture that is rigorously evaluated, scalable, and private.
Establishing a sovereign intelligence network allows an organization to build lasting equity instead of paying interest on rented code.